Hi, so we are going to do more questions related to arithmetic sequences and series, so let's just start. Question 13. The sum of the first n terms, s of n, of a particular arithmetic progression is given by that thing. Is 4n squared plus 3n. So find the first term and the common difference. Well, you're given sum of n terms. The sum of one term can only just be the first term, right? So a is just sum of 1 is 4 times 1 squared plus 3 times 1. So a is just 7. And the common difference, well, you can find the sum of two terms, right? That would be 4 times 2 squared plus 3 times 2. 4 4s are 16 plus 6. That is 22. And we know that we said that T2, or the nth term, is given by Sn minus Sn minus 1, right? We discussed this formula. So T2 is given by Sn, sum of n terms, which is so n S2 minus S1, right? Because these are matching. So, and we looked at this formula in the previous video. So S2 is 22 minus S of 1 is just 7, right? And 22 minus 7 is 15. So we know that T1, which is A, is equal to 7, and T2 is equal to 15. So therefore, D is T2 minus T1. So the common difference is not the difference of the sums, it's the difference of the terms. So that is a mistake that you might make. So T2 is 15 minus T1 is 7, and therefore 15 minus 7, that I believe gives you 8. So your first term is 7, your common difference is 8. All right. So essentially, this is the same question, right? It says find the first term and the common difference. So 14 is the same question as 13. So I will leave that to you. So please use the same idea that we did in 13. Find S1, find S2. Using S1 and S2, find T2, and then find common difference. So that is, we'll move on to question 15. So it says the sum of the first n terms of a particular arithmetic progression is given by this expression. So let's just look at the question properly. The sum of n terms is given by 1 over 4, 5n squared minus 17n, right? And it says find an expression for the nth term. All right. So we will always find what we can. So we can find the first term, right? The first term is given by 1 over 4. 1 squared is 5 minus 17. 5 minus 17, that is negative 12. And I believe the first term is negative 3. And that is also A. So now if you think about it, you know that the sum of n terms is always going to be n over 2, 2a plus n minus 1d, right? And we are given what this expression is. This expression is just this. But there is another way to write this. We know that this is also n over 2, a plus the nth term, right? A plus the last term, and the last term is always the nth term. So a is negative 3, so I can write it as negative 3 plus tn, or actually tn minus 3. And Sn is just 1 over 4, 5n squared minus 17n. And now if I divide by n on both sides, I get 1 over 4, 5n minus 17, right? N squared divided by n is just n, and 17n divided by 17 is just 17. And then I have 1 over 2, tn minus 3. So if I multiply by 4 on both sides, this 4 will cancel out, but you are free to simplify as you want it. So 5n minus 17 is going to be 2, tn minus 3. And that is just 2tn minus 6. And if I add 6 on both sides, I get 5n minus 11 is equal to 2tn. And therefore, the nth term is given by half 5n minus 11. So that is the answer for 15. Half 5n minus 11. All right. Let's go to question 16. That looks interesting. A circle is divided into 10 sectors, and the sizes of the angles of the sectors are in arithmetic progression. All right. So we have a circle and we have areas. So we have a circle, and the sector just means that take the midpoint and we're dividing it into 10 parts like this. And the angles are getting bigger, right? Because bigger angle would give a bigger area. And let's just say they all have the radius r. So this is a circle, this is what we call a sector. All right. So angles, the sizes of the angles are in arithmetic progression. So we have 10 angles. We will have theta 1, theta 2, theta 3, all the way. So let's just say these are our angles. Theta 1, theta 2, theta 3, all the way up until theta 10. So that is our angle. The angle of the largest sector is 7 times the angle of the smallest sector. All right. So we are given that theta 10 is equal to 7 times theta 1, right? Because the smallest sector corresponds to the smallest angle. If you think about it, right? Sorry, let me just pull this down. All right. So if I just if I have a smaller angle and if I have a bigger angle, then you see that a bigger angle gives me a bigger area. A smaller angle gives me a smaller area. So that tells me that the angle of the largest sector, which I will say is theta 10, and let's just assume that this is in an increasing order of the angles, right? Is 7 times the angle of the smallest sector, so theta 1. So find the angle of the smallest sector. All right. So theta 10 is also theta 1 plus 10 minus 1 is just 9 times the common difference is equal to 7 theta 1. And you know the 9 times the common difference is 6 theta 1. So if we know the common difference, we know that if we know d, we know what theta 1 is. So we know this relationship between d and theta. And what do we know? Well, we know that if I add all the angles together in a circle of these parts, we get 360. So I know that the sum of the 10 angles has to be equal to 360 degrees, right? So sum of 10 terms, I would say. So this is one thing that I saw. It does not necessarily mean that it's useful. So I know that, hey, if I do S of 10, that is just 10 divided by 5, and my first angle plus my last angle, right? So that is going to give me 360 degrees. And I know that the biggest theta 10 is just 7 times theta 1. So actually, I have 2 theta 1 plus 7 theta 1 is just 8 theta 1 is 360. So I have 16 theta 1 is equal to 360 degrees, and therefore theta 1 is equal to 360 divided by 16 is equal to 22.5. Sorry, this, yeah, that is correct. That should be 10 divided by 2. So this should be 5. I'm so sorry. So the formula is just 10 divided by 2, a plus L, right? And L is 7 theta 1. So the last angle, theta 10, is 7 times theta 1. So we have 8 theta 1, and 10 divided by 2 gives me 5. So this has to be 40. And that gives me 9 degrees. So you can look at this way, but this was not useful. And we could figure out from our circle, another fact about the angles is that the sum of the 10 angles has to add up to 360 degrees. So when I use the fact, and when I use that my last angle, the biggest angle, is just 7 times my smallest angle, theta 1, then I can simplify to get my smallest angle to be 9 degrees. So that is how you would do question 16. So I'm so sorry I made like a division. I'm making a lot of errors in the more recent videos, so I'm so sorry about that. So question 17. An arithmetic sequence has a first term a and a common difference d. So our standard a and d. The sum of the first 20 terms is 7 times the sum of the first 5 terms. So sum of 20 is given to be 7 times the sum of the first 5 terms, right? Sum of 20 terms is 7 times the sum of the first 5 terms. So 7 times sum of 5 terms should give me the sum of the 20 terms. So it says find D in terms of A and find the 65th term in terms of A. So we want to write D in terms of A. Alright, so sum of 20 terms, that is 20 divided by 2. And I know that that will be A, 2A plus 20 minus 1D, right? That's what the formula tells me. So that is just 19D. And then 7 times sum of 5 terms, that is just 5 over 2. And I have 2A plus 5 minus 1 is 4D. And I can actually factor out the 2 here. So this is just A plus 2D multiplied by 2. And when I divide by 2, those things will cancel out. So I have A plus 2D, 7 times 5 is 35. And 20 divided by 2 is just 10. So I have 20A plus 190D is equal to 35A plus 70D. So if I take 20A to the other side and 70D to this side, I get 190D minus 70D is equal to 35A minus 20A. So this has to be 120D, I believe. 35A minus 20A is just 15A. And therefore, A is going to be 120 divided by 15D. So that is, I believe, 6D, if I'm not mistaken. Sorry, it's going to be 8D. So we know that A is equal to 8D, and we're asked, find the 65th term in terms of A. So T65 is just A plus n minus 1, which is 65 minus 1, 64D. And we know that, so it asks us to write in terms of A, I believe. In terms of A. So find D in terms of A. So this works, but I would prefer to write it as D is equal to A divided by 8. I would prefer to write it this way. So D, because this just tells me D in terms of A, right? So T65, we need to find it in terms of A. So I will just substitute D is equal to A divided by 8. So A plus 64 by 8 is just 8A equal to 9A. That is your answer. Alright. Question 18. Question 18 tells me that the 10th term in an arithmetic progression is 3 times the third term. So T10 is equal to 3 times T3. Show that the sum of the first 10 terms is 8 times the sum of the first 3 terms. Alright, this is an interesting problem. So let's see what we can get out of this. So T10 is just A plus 10 minus 1 is 9D. And D3 is equal to A plus 2D. So I know that A plus 9D is equal to 3A plus 6D. And if I simplify, if I subtract A on both sides, so if I bring 6D here and A there, I get 2A. 3A minus A is 2A. 9D minus 6D is 3D. And I will use this relationship. So this, I think, will come handy. So it says, show that the sum of the first 10 terms. So sum of the first 10 terms is just going to be 10 divided by 2 is equal. And then we have 2A plus 10 minus 1 is 9D. So that is 5 times 2A plus 9D. And that is 10A plus 45D. Right? And now we can substitute. We know that 2A is equal to 3D. So you can substitute D, you can substitute A, but I feel more comfortable substituting A in this case. So if 2A is 3D, then 10A, so 2A is equal to 3D. If I multiply both sides by 5, then I see that 10A is 15D. So 10A is 15D plus 45D, that gives me 60D. All right, now let me calculate S3, right? S3 is just 3 by 2, 2A plus 2D. And we know what 2A is. 2A is just 3D. The 3 over 2, 2A is 3D plus 2D. So we know that this is 3 over 2, 5D. Now we see that if I multiply 8 times S3, so So 8 times 3 over 2, 5d, I get that 8 divided by 2 is 4, 4 times 3 is 12, times 5d is 60d. So therefore, we see 8 as 3 is going to be as 10. So 8 times our third sum of the first 3 terms is equal to the sum of the first 10 terms. Alright, so we used what we were given as a fact. We got a relationship between our a and d, and then we used it to prove what we were asked to prove. So that is how you do question 18. Question 19. The sum of an arithmetic progression is, the first term is sine squared x, and the second term is 1. So we know that a is sine squared x, and t2 is 1. So d is just d2 minus d1 is equal to, what is t2? 1 minus what is t1 is sine squared x. Now if you remember, sine squared x plus cos squared x is equal to 1. So cos squared x is actually 1 minus sine squared x, right? And that is exactly what we have here. So d is just cos squared x. So now question part A says, write down an expression in terms of sine x for the fifth term of this progression. Well, t5 is just going to be t a, that is just a, t1, sine squared x, plus 5 minus 1 is just 4 times d. So we want to write it in terms of sine x. So instead of using cos squared x for my d, I will just substitute this. 1 minus sine squared x. So that gives me sine squared x plus 4 minus 4 sine squared x. So sine squared x minus, so that is 4 minus 3 sine squared x. So that is your fifth term in terms of sine x. And then it says, show that the sum of the first 10 terms of this progression is 10 plus 35 cos squared x. Alright, so sum of the 10 terms will be 10 over 2, right? That is 5. And then I have 2a, so 2 times sine squared x, plus 10 minus 1 is 9. D is going to be, now because my answer is given in terms of cos squared x, so I will substitute my d to be cos squared x. And now I can write this as 10 sine squared x plus 9 fives of 45 cos squared x. But we want to write everything in terms of cos x. So 10 sine squared x is 1 minus cos squared x. You get this from the same formula. Sine squared x plus cos squared x is equal to 1. So sine squared x is just going to be 1 minus cos squared x, right? Plus 45 cos squared x is equal to 10 minus 10 cos squared x plus 45 cos squared x. And finally, the final answer is 10 plus 35 cos squared x, which is what we're asked to prove.